Question number 30. The specific heat at constant pressure is greater than that of the same gas at constant volume because what? Okay, so to understand this question or to solve it, let's analyze what happens to the heat energy that you give to any gas. It is utilized in increasing the internal energy of the gas as well as doing work. Right now, let's understand this based on two processes. One is at constant pressure. When pressure is constant, what happens to the heat energy supplied to the gas? Q equals to delta U plus W. And how much Q? N into Cp into delta T. Right. Delta U is solely dependent upon this delta T temperature. So delta U, let's call it as delta U plus P into delta V. So from here I know what is the value of Cp. Now in the second scenario where volume is constant, what happens to the heat energy supplied to the gas? Now here work done will be 0. Why? Because change in volume is 0. So how much heat energy are we supplying? NCV delta T is equal to delta U. Now look carefully, the change in temperature is delta T in both the cases. So delta U has to be same, right? So this delta U and this one both are same. So I can replace this delta U with NCP delta T minus of P delta V. From this equation, we can definitely tell which part is very high. If you compare NCV delta T and NCP delta T, which is more? NCV delta T is less than NCP delta T, isn't it? Or we can also infer that Cp is greater than Cv. Right? Now if you want to put it in terms of statement, what happens? If you look at the first scenario, the heat energy that is supplied is increasing the internal energy of the gas by delta U, that is first part. At the same time, it is also doing some work. The gas is doing some work. Right? So I have to supply more amount of heat energy to do the work. Whereas in second case, that is in constant volume, whatever the heat energy we supply is used for increasing only the internal energy. So I have to supply less amount of heat energy. So let's look at option A. At constant pressure, work is done in expanding the gas. That is true. Looks like option A is correct, but let's go through the other options as well. Option B says at constant volume, work is done in expanding the gas. Option B is impossible, right? When volume is constant, gas cannot do any work. Molecular attraction increases, molecular vibration increases. These are all useless options. Option A is the correct one, right?